Hi all, I'm back to your regular videos talking about solving systems of equations with more than two variables. Now, most students I've found have run into these before. We're going to add one new idea here, so if you're feeling like, I really remember how to do this really well from last year, fast forward until number 3, because you're really going to want to see that for number 3, because that is going to be the new idea. Now, for those of you who are feeling a little bit more rusty, what you want to do for these is I'm going to still use elimination as my method for solving. So get yourself ready for notes, and we're going to talk about how to tell which ones to eliminate. Now, what I'm going to do here is I'm going to look at my system here. We've got 1, 2, 3 variables, so we have 1, 2, 3 equations, and I'm going to look for the ones that maybe have like terms already. If they don't, I would, be like, oh, here they're close. I'll just multiply these two by 2. But in this case, we have a set of like terms here. So I'm going to rewrite these out with the negative one in the middle. And that might seem a little silly, but there's a reason for it. So x plus 2y minus z equals 13. And I'm going to change that negative one to the middle, so x minus 2y plus 3z is equal to negative 1, and then 2x plus 2y minus 5z is equal to 3. Now, basically what I'm going to do is I'm going to eliminate with both of these. So the reason I reordered it is because those eliminate, and these eliminate, because one's positive, one's negative, and I can combine them into two new ones. So these two together would combine to 2x plus 2z here. So 2x plus 2z is equal to 13 and negative 1, which is 12. And then the bottom two also eliminate the y's. So then we get 3x minus 2z is equal to 2. All right. So, again, just checking that I haven't dropped any negatives here, right? We've got 2, 2z, 12, and then 3x, negative 2z, and 2. So now I'm going to use elimination again. The nice thing here is that the z's will cancel out, and I'm left with 5x is equal to 14, like so. What that tells us here is that x is equal to, we could either say 14 over 5 or 2.8. Either way is fine. If you prefer fractions, if you prefer decimals, that works for me. Now that we know what x is, I'm going to say, all right, let's solve for z. So solve for z, and that means I'm going to use one of these two equations here. And I'm just going to use the first one. So 2x plus 2z is equal to 12. We know that x is equal to 2.8. So 2 times 2.8 plus 2z is equal to 12. Now I'm going to be a little sneaky here, and I'm going to divide everything by 2 and say 2.8 plus z is equal to 6. So z is equal to 6 minus 2.8, which would be 3.2. So now we have an x value and a z value. So our final step is to solve for y. Now, we want to go all the way back to one of our original equations. We know that x plus 2y minus z is equal to 13. Whoops, sorry about that. X is 2.8, 2y, z is 3.2, all together is 13. So then I get 2y minus, I can combine 2.8 and 3.2 together, which will give me, okay, let's see, negative 1, negative 0.4 is 13. Just checking there, making sure that I'm following that along. And so then 2y is equal to 13.4, meaning that y by itself is equal to 6.7. So our final answer is going to be 2.8 for the x value, 6.7 for the y, and since there's 3 variables, you could just add it along, like so. So this one obviously designed to work out really nicely. Now, what I want to look at is another one. And these two are going to have different things about them. So we're going to use similar method here, except for unfortunately, none of the variables perfectly cancel out. But yeah, this is 4, and these two are both 2. So I'm going to multiply this top one by 2, the second one by -2 to make that middle one the negative. So then I get 2x plus 4y minus 4z is equal to 2. And negative 4x minus 4y minus -2, so plus z, is equal to -12. 3x plus 4y minus 3z is equal to 5. So again, we'll do the same thing. Consider the first two, those cancel. We're left with -2x minus 2z is equal to -10. And for the second ones, the y terms again cancel. And so I get -x minus z is equal to -7. Combine these two, multiply by 2, and I end up with -2x minus 2z is equal to -10. -2x minus 2z is equal to -14. Well, when I combine those, the x terms cancel, the z terms cancel, but the others don't. So I get 0 is equal to -24. This is not true. 0 is not equal to -24. Whoop, I dropped a negative there. But so negative, positive. So then 0 is still not equal to 4. So since 0 is not equal to 4, that means that there is no solution to this system. Of course, that also means that there are infinite solutions, and this is the one that's different. Well, I will expect more of you. Here, we can see our a terms are all already ready to be set up, but there's no negative, so I'm just going to go through and make that middle one a negative and combine so that the a's cancel out. So I get -3b plus 6c is equal to -6. And for the second set, here, again, the a's cancel out, and I get -5b. Sorry, not -5. That's a +3. Negatives today, I tell you. Minus 6c is equal to +6. So these all cancel, leaving us with 0 equals 0, which is true. And so this means that there are infinite solutions. Now, up until now, you have been fine to just say, oh, there's infinite solutions. That's fine. Now, there are infinite solutions, but they aren't just every single number ever. Their infinite solutions are a line. So if you think about with the graphing problems, if you said something had infinite solutions, it would be a line like this. That line has an equation, so I want you to solve for linear form. So that means that you should have mx plus b. Often you're not going to, x isn't the one that's easiest to solve for. Often it'll be one variable or the other. So in this case, I'm looking here and I am going to say, well, we know that 3b minus 6c is equal to 6. So this is that last equation that we just solved for. I think given this, it's easiest to solve for b in terms of c. So ask yourself what's easier. And in this case, it's like, oh, I'm going to solve for b in terms of c. So that means add 6c to both sides. So 3b is equal to 6c plus 6, meaning that b is equal to 2c plus 6. Now, since it's in terms of c, that's basically going to be you can treat that as your x value in your linear form. And you just have to have the same term consistently. So if it's easiest to solve for A, and that's going to be your consistent one. And I'll show you how I want the final answer written. So now we know, we can say that like C equals C, B is equal to 2C plus 6. So now we just have to solve for A in terms of C. So to solve for A in terms of C, I'm going to just take that first equation, 2A minus 2B plus 10C is equal to negative 4. I want to solve for A, so then I get 2A is equal to 2B plus 10C minus 4. I don't want B, I just want C. I'm going to divide first by 2, so A is equal to B plus 5C minus 2. And we know that B is equal to 2C plus 6. 5C minus 2, so A is 7C plus 4. Now let's just quick again, make sure I didn't drop any wild negatives here, as I have been in a habit of doing, and I have. This should be minus, so then this should be minus, so then this should be minus. So minus 10 minus minus. All right, and then this, I'm not having my best algebra day, it should be 3, 3, like so. And so then when we, oh, no it shouldn't, it should be 2. Goodness gracious me. And that's why it's always so important to share your work, so you can go back and change very easily. So then 2C plus 2 minus 5C is negative 3C. So the way that you write your answer, A first, which is negative 3C, B, which is 2C plus 2, and then C, which is C, like this. If you have questions about this and my frankly atrocious algebra skills, please let me know, and I'd be happy to work you through it.